Welcome, and thank you for joining the fight for climate change, the fight for keeping the world a more sustainable place to be for our future generations. Today, I'm going to present you one of the most exciting research facilities we have. I am Francesco Finotti, Research Manager from Sintef Energy Research, and today we'll present you one of the most exciting facilities our company has to offer. It's called DeFACTO, and it stands for Demonstration of Flow Assurance for CO2 Transport Operation. We'll go through the challenge. I'll show you the DeFACTO facility, how it is, what is the background for it. We'll show you some picture, and then we'll take a virtual tour of the facility. Stay tuned. The reason for DeFACTO is, as we know, there is a huge amount of CO2 that's being emitted by human, and what we want to do is to reduce that amount of CO2. One of the ways to do that is to employ CCS. CCS stands for Carbon Capture and Storage, and is a technology, or is a spool of technologies used to limit or to reduce the carbon emissions of the planet. DeFACTO will help ensure safe and cost-effective CO2 transport and injection, which is sort of a part of this big puzzle of CCS. So this will enable a safer and more cost-effective transport of CO2. DeFACTO is located on Glashaugen. It's in the NTNU campus on top of the building. You can see the building here in yellow. And this big tower that you see on the right, it's a big DeFACTO tower. It's sort of the CO2, is the top of the 90-meter deep well that is circulating CO2 down into the earth and returning it back. So there is no CO2 release, at least not in the well. Let me explain you better. We have a tower, and the tower is connected to a big U-loop. The U-loop is 90 meters deep, and it will circulate CO2 down up to 90-meter depth and up back. The idea is to sort of test CO2 circulation and CO2 operation. The loop is instrumented with 100 high-frequency sensors, pressure and temperature. It's over 100 kilohertz for the most high-frequency readings, so it captures waves quite well. The loop is divided in two pieces. One piece is 16 millimeters ID, the second loop is 32 millimeters ID, which means that we can circulate both down and up with different diameters, which is very interesting because we can check both on the heat transfer coefficient, but we can check how the CO2 circulates down the well and which type of phase will it have. So for example, we can inject CO2 gaseous and then see if it condenses in the well, or we can inject it liquid and see if it's become gas throughout the well, depending on the heat transfer between the fluid and the CO2. About the heat transfer, it's very important to mention that there is a temperature control of the whole borehole. We have a water circulation system that controls the temperature between 5 and 35 degrees, and that water circulation system is sort of able to control the temperature so closely to the temperature that we want, that we can sort of keep the temperature of the whole borehole constant while we circulate CO2. This helps to estimate the heat transfer coefficient and to make sure that that heat transfer coefficient stays as stable as possible in such a large facility. On the top of it, we have a vent that can be release CO2. So CO2 can be both circulated steady state, circulate dynamically, so changing the condition on the go, or also vented throughout this big yellow vent that you see on the top of the facility. DeFACTO is a CLIMIT demo project funded by Gasnova with the support of Equinor and Total. Here is a bit of the schematic of how the DeFACTO works. As you see, there are two different loops, one with CO2 and one with water. The water loop circulates water in the well and returns it to keep the temperature stable. And the CO2 loop circulates CO2 in the U-tube, up and down. We have a container that is used for conditioning CO2, and we have inside the container there are two tanks, one high pressure and one low pressure, that we can use to circulate the CO2 from one to the other tank. There are compressors and pumps in between so that we can keep the condition as controlled as possible. There is also a conditioning system inside the tower on the top of it. So that helps to sort of keep the CO2 in controlled condition at all times. The knowledge gaps that we're going to solve is both single and two-phase flow of CO2 with impurities, and then we have a steady state flow at different temperature and pressure condition and gas to liquid ratio. We can try with transient, shut-in first fill, we can try depressurization and fluid hammers, and we can also look at the reservoir backflow. So there are a lot of type of experimental activities that we can run, a lot of experiments, and many are quite interesting and unique in literature. As you see on top, there is this graph that show the couple of tanks, and in between the two tanks we also have a horizontal loop that is long 139 meters. It's a small loop that was built several years ago, but it's still very relevant to sort of circulate and condition the CO2 to prepare them for injection in the well, or at least for circulation in the well, to be more correct. The well circulates the CO2 downwards and upward, and I said is instrumented with the temperature and pressure sensors along the way. The high frequency can help to capture the waves and the depressurization wave, and it helps also understanding where the CO2 changes phase, if it does, during the loop. So DeFACTO supports the vision of reducing CO2 emission in the world by validating CO2 flow and injection models. It also ensures safer and most cost-effective CO2 pipeline design, because we can reduce the engineering margins on the pipeline designs, and this to ensure a better profitability for CO2 capture and operation worldwide. Now a few pictures of the facility. It's kind of very interesting. I hope you've seen some of them in the introduction video as well, but let's see some pictures here. This is the bottom section. The bottom section is composed of sort of three big pieces. You can see there are two valves in yellow. There are actually three. One is behind, you don't see it, but it's there. And there are three actuated valves to sort of open and close individually the branches that we showed just before. There is also something that is called the spring, that is to induce to help with thermal stresses, so that the hydraulic lines can have some space to go up and down in case there are some thermal variation in the temperature in the column. We also have a water injection line that you can see with this big hole. It's the water circulating from down and returning back in the annulus to keep the heat transfer coefficient as stable as possible. And those are a bit of the picture from the installation. It's been a quite interesting project. It's been a challenging installation. Think about it, the casing is 219 millimeters ID, and inside there we have over 100 cables with 6 big lines, both hydraulics and CO2. So you see the margins are very tight, and it has been a very exact operation to actually keep it as close as possible to the sort of borders of the design. So the whole design has been very interesting, and the process of installation has also been kind of funny. Now it's built, and there is a big tower in Gloshagen, and this tower is used by researchers worldwide that come here to experiment on CO2 injection and transport. So it's very exciting to see now that researchers from abroad are asking to come here to be part of this big experiment on this project.